And I said, you're kidding, right? And he said, no, this is what we have to do. We got to keep the smell out of the dining room. We've got to keep, the fryers and everything going. I said, have you ever once thought about running 4-inch pipes right under your concrete slab, straight through the concrete, right up behind the fryers, and have that come to your Haltom vent? And now you're supplying air right behind the fryer. You're taking the grease right out there, and you're not affecting the rest of the restaurant. The guy goes, oh my gosh, what is it you do? And I said, building science. Wow.
This is the one and only, the original podcast where you can find yours and your business's true value. You're listening to Our Value.
Brought to you by America's insulation source, IDI Distributors.
You want to hear from the best contractors, suppliers, and consultants that dedicate themselves to more than just survival in the business world?
Industry professionals that are dedicated to excellence in every aspect of their business.
Our Value has them all here to share that same motivation and knowledge with you. Tune in and grow a more successful, profitable, educated, and recognized business. Listen to the Our Value podcast to become the industry leader in your market. Find your value with Our Value.
Welcome to today's Our Value podcast. Today we are working on something I've had a few people ask. I ask them, hey, do you ever build passive house? And all I hear is, what's passive house? Well, we are going to try and demystify that today. So I am talking with Ken Levenson. He is the executive director of the Passive House Network. I figure if you're going to ask somebody, go to the top. He's also a recovering architect or an architect from the past. Like he said to me just a minute ago, once you're an architect, you're always one. So we will be careful here.
Don't hold it against me.
No, I'm just kidding. So how are you today, Ken?
I'm good. It's great to be with you. Looking forward to the conversation.
Well, I'm glad you had the time. So I'm going to start right in with, if you had to give an elevator pitch, you've got somebody, you meet them you're standing in line at Starbucks, and you say something about Passive House Network, and they say, what is Passive House? How would you answer that?
Yeah, it's a great question. I would say that Passive House is looking to optimize the structure of the building. It's about an envelope first approach, about how well insulated and how well the container of the building works, so that it is the most resilient it can be. It provides comfort, very good indoor air quality, all while requiring very little energy. So if you want low energy bills, if you want really good indoor air quality, if you want good thermal comfort, you want a passive house.
I like that. I have to admit to you, we had a problem with the pool, a leak. And I go running outside. The pool guy was there. I said, hey, I've got a podcast in just a minute. I'm going to jump on and talk about Passive House. Guess what he asked me? What's passive? So
Exactly.
I told him, I said, well, in Europe, it's R100 ceilings, R60 walls, but it's really a building you can heat with a candle and cool with an ice cube. And he goes, I want one. So
yes, that's a great analogy or image to do, is like literally if the power goes out in the middle of a winter storm, you can be safe with a handful of candles.
Well, and we're here in Texas. What happened 3 years ago? We froze the state. And that was his first thing. He goes, oh, I'd really like a house like that. Yeah. So I thought that was pretty cool. How does Passive House compare to a traditional build? Like say, now that we're looking at the 2021 code, if we build to 100% of that, we're almost to, net zero energy ready home or net zero energy ready home.
Right.
So how does it compare to that?
So it shifts a little bit in terms of the thinking. So traditionally a building is more or less looked at as a kit of parts. You've got the R value for the walls, the roof, you've got the performance of the windows, and then you're sizing your mechanical equipment. But it's not looked at in terms of how it all works together and can be optimized to minimize the energy use, to minimize the reliance on mechanicals, and optimize the thermal protection of the enclosure. So you may typically have in many climates triple pane windows rather than double pane windows. You may typically have more insulation. You'll have a more airtight enclosure. You'll have a more robust ventilation system, but your heating and cooling system could be dramatically smaller, as much as 75% smaller. what you're doing is trying to design in a balance of the economics and the resources to really hit a predictable, optimal performance. We're looking at reduction of energy use of up to 75% for a building from conventional. And so this is really different from even a net zero building or a near net zero building, because the near net zero building is still looking at it conventionally as a kit of unrelated parts, essentially. Again, be more efficient, trying to use less energy. But really, at the end of the day, it's about energy production. It's about the solar panels and how much you're going to do. So you could have a net zero energy building that's super efficient and super resilient, or you could have a net zero energy building that's really inefficient and really unresilient. So when we do a passive house, we like to electrify, but we want to rely on that as little as possible. So it's kind of a paradigm shift, if you will, away from just saying, okay, more is better, like more insulation is better. Certainly we want, I like to use the analogy of the typical housing construction today is like my teenage kids in wintertime going out with a hoodie on and nothing else and saying, I'm fine, I'm good, no problem. This is acceptable. And we're like, you've just got a sweatshirt on and it's freezing out. That's insane. And a passive house is going to be the person, myself or other parents, who put on a parka, who put on a hat, who put on a scarf, and gloves, and proper boots, and you're warm. And you don't need to have an active heating system underneath your parka because your body is keeping yourself warm. And that's what's happening with a passive house. All the efficiency and the code updates are good, and it's moving towards this. But passive house is kind of saying, we know what we need to do to hit the end mark in terms of optimal performance. Why not just do it? And then you're resilient. Then it can be a heat wave. It could be a polar vortex. The power can go down. You can wait for the utility to come back on, and you're going to be safe and comfortable and know you're protected.
Cool. I like that. I also like how, I've always told people, if we went skiing, would you be any warmer if I told you to eat your coat? And they're like, what? I said, well, that's what you're doing in houses. You're forcing them to
Exactly.
eat their coat and leave their skin exposed. I like how you compare thermal bridges in a traditional build as, death by 1,000 cuts. Can you talk about how passive house addresses thermal bridging?
You're pointing out a really another key difference between conventional construction and passive house. So we've got the insulation, which is wrapping and is continuous as we can, but oftentimes there are breaks in that insulation all over the place. It could be the cavity studs, if it's cavity insulation. It could be structural pieces, and where walls and floors come together, and you have this discontinuity of the insulation. And traditional construction is not really taking them into account in the overall performance and the degradation of the performance. Passive house, because we want to optimize it, it recognizes how much of a factor those thermal breaks can be, and the thermal bridging, where you have breaks in the insulation, can be. And it forces you to put them into the model and account for them. And you realize, it can make all the difference in the world in terms of the ultimate performance. And if you want to so a home I did as an architect early on as a passive house retrofit, the traditional home next door had 12 to 15 tons of air conditioning on it for heating and cooling. We calculated that we needed 1.5 tons, which is like a living room unit. And it's a big house, 15 tons, 12 tons of air conditioning for a typical one. And, they're spending a good amount of money on a custom home. And it's like, you're going to put in what? You better be damn sure that you're hitting the numbers. So there's always variability in a passive house. You're going to have user differences. You're going to have weather extremes. You're going to need some bandwidth. So we doubled the size to 3 tons. But our band is from 1.5 to 3 tons, right? Not 10 to 15 or whatever it might be up there, where the engineers are just doubling the size because they don't want to be sued at the end of the day. And so if if you are calculating into that kind of, predictive bandwidth, you need to take care of this thermal bridges.
We've been really blessed here in the United States to have cheap energy. I'll just say
Yeah.
it, so it's not like we really, it's that
Yeah, no,
said,
that's the market.
yeah. And that said, I've believed for years that most things to our customers are not energy savings. They're not the most important things.
Right.
But comfort and health really are. Those are the things that they'll pay beyond measure for. So how is it that Passive House addresses or protects health?
Yeah, no, it's interesting. And it's one of the kind of revelations, if you will, of around Passive House and the way that they've recombined. And again, it's basic building science, right? We're not talking about rocket ships here. It is basic building science, basic ingredients. I like to use the analogy of cooking. You've got the same ingredients, or you can have the same ingredients, and you can make an incredible meal, or you could make something that's inedible, right? And so what you do with them and how you think about bringing them together and knowing how they react together. And so with Passive House, and my early client, the same one where we had this dramatic renovation and looking at the sizing of the equipment, they were similar. I mean, they were focused on comfort and the health of their kids and the resilience. They were great to hear that it would be helpful to the environment and be more sustainable, but they weren't doing it for that. Just as you said, it was like, wow, this is going to be more comfortable, and it's only going to cost me a little bit more. And we'll talk about the cost, I'm sure, in a little bit.
Oh, I'll get there. Yeah.
Yeah. So what it does with this basic building science ingredients is it showed how to align, like the functional definition of Passive House kind of aligns hygienic ventilation. So you're providing 100% fresh air with heat recovery, no recirculation of air. So it's all exhaust, all supply, filtered. So you have cleaner air indoor than you have outdoor, especially if you're near polluted areas, highways, forest fires, things like that. And it combines that with the need for a low energy state of heating and cooling. And so Passive House, actually, the more efficient you are, the more comfortable, and the definition of thermal comfort. So you have hygienic ventilation, energy efficiency, and thermal comfort, these three legs all rowing in the same direction. So how does that work? For example, there's kind of a iconic picture of two young kids that we use sitting in front of a Passive House window in the middle of winter. And the Passive House window, because it's triple glazed, it's truly thermally broken, it's airtight, that interior surface of the glass, the temperature is close enough to the other surfaces of the room that you don't get convective currents. You don't feel the glass pulling the heat off of your body. You don't have to make up for it with a radiator right under the glass and overcome it. You have a basic thermal comfort delivered by the envelope. In this case, the insulation in the walls, of course, but the insulating value of the window itself and how it's installed. So that's working along with the fresh air that's coming into the room. With the heat recovery now, the heat recovery can be over 90%. So you can have freezing air come in within a couple of degrees of the room temperature at a very low volume, and it's just continual 24/7. And so again, you don't have this disruption of comfort that you have to overcome with other mechanical systems.
I thought that they were around 70%. You're saying you've got ERV, HRV units that can
over 90%.
Go up to 90?
Yeah.
Wow.
Over 90. Yeah,
over 90.
Yeah.
We need to
so
talk.
that makes a huge difference in the energy model. Like thermal bridges, the heat recovery effectiveness of the ventilation system can dramatically change. There's actually one leading manufacturer, an American manufacturer of a Passive House certified. Yeah. It's not all coming from Europe anymore. And
I
American
love it.
manufacturer of Passive House certified ventilation that comes in over 90%. They are outfitting steakhouses with Passive House level ventilation systems so that they can run that ventilation that the owner was thinking about and get the ventilation without losing the heat.
Wow. That's
Yeah.
fantastic.
Yeah, so it's a game changer in a lot of different ways, and it has a lot of different applications. And we see, the other thing, and I'm sure we'll come around, passive house, we think of homes for certain, but it really started with multifamily, and it really blew up with affordable housing in Europe, social housing, and we see a lot of affordable housing happening in the US with passive house as well, because what we're describing here is just basically high quality construction, right? And so what's great about it is you're bringing high quality construction to every socioeconomic group just through acknowledging the basic building science and giving them much better. And you're realizing that the market rate housing isn't so great necessarily, and that the wealthy people aren't necessarily in better buildings. They're just in more luxurious buildings. And so the benefits, again, going back to my first house, it was, this was a Wall Street person and they had the means, and, they could have just overpowered it with energy and been done with it and paid the bills. But it appealed to them of the economics and the efficiency. It was like a sensible thing to do. So
I like that. It makes me think of a few things, but when we teach retrofit during our classes, I'll tell them, look, a 1,200 square foot house, you're not going to find a whole lot. There's not a whole lot of room to hide bad construction. I've seen 5,000 and 7,000 square foot houses where you can find, air quotes, opportunities all over the place.
Yeah.
So I've heard you talk about, you mentioned the Wall Street guy. I've heard you talk about mitigating investment risk, which I'm sure that plays into multifamily as well. But
yeah,
I want you to talk about that because, obviously every building's an investment today with the cost of housing.
Right.
No matter what level you're at, it's an investment to have a property.
No, absolutely.
So talk about mitigating investment risk and how passive house, connects to that.
Yeah, absolutely. So, I mean, the bottom line is we're living in times of more extreme weather and unpredictable weather systems, and we can expect that to only grow going forward. And so if you're dealing with an exterior environment that is growing in unpredictability, the best thing that we can do is make the enclosure, our shelter, more predictable, and so that it's more resilient. And what we see, it's not the same. Like, one thing that passive house, you could build a passive house anywhere, do it out of whatever materials that you want to. There are certain things that you do to like make it more predictable and make it more sustainable in any number of ways and more resilient. But we see, I think, like I saw an article where, low-lying areas are starting to just naturally depopulate, where you have greater flood potential, right? And so neighborhoods that are going to have a tendency to flood, we see people aren't so anxious to buy into them anymore. And so there's a natural tendency to move that way. Passive house is kind of doing that with all the other weather systems, it's giving people a choice to go somewhere that is going to provide a shelter that's going to get them through and last. Basically, we call it future proofing. So whatever happens with energy, the other thing that risk mitigation and going into the future is you have just the physical comfort and resilience, but you also have energy prices, right? So energy prices we can safely assume are going to go up at some rate in the future, as they always have in the past. And there could be more unpredictable as energy sources switch or become disrupted for whatever reason. So if you've reduced your energy demand by 75%, you've got a much less rise in costs, right? If you're starting at such a low baseline. So if energy prices double and you've got 75% less demand, you're in a much more financially secure position.
I would agree with that. I know, because you mentioned resilience a few times. We're one of the biggest trainers when it comes to spray foam contractors.
Mm-hmm.
And we move a lot of liquid, but we've had a lot of spray foam contractors, and many of them know about the study that was done by NAHB, which shows 2 inches of closed cell foam and a 2x4 wall will increase the racking strength by 300%. But it's also the only FEMA approved insulation, meaning it can be underwater 72 hours.
Right.
You don't have to take it out, which, makes total sense. But there's some areas where you can get a discount on your insurance for using it. How does Passive House really address that building resilience? And are there any similar financial benefits? Like, have you heard of anyone getting a discount on their insurance based on Passive House?
Well, I have not heard of anything directly tied to insurance in that way. The only incentives that we've seen are, not for single family homes, not directly tied to Passive House per se. It's the general incentives that are out there for doing more efficient building. What we see for incentives for Passive House tend to be for multifamily and bigger buildings and affordable housing and how the tax credits are structured. So we'd love to see the insurance industry take it up. It's a huge lever.
It is, but also I thought I'd heard that Colorado incentivizes building to Passive House standard. Like,
yes, actually, that's a great, yes. Thank you for,
and are there other states? Yeah. So, yeah.
Yeah. So, well, that's interesting too, because the utility is Xcel Energy. And so Xcel, after the Marshall Fire, where 1,000 homes burned down in Boulder County, and to rebuild, they offered a tiered incentive program for Energy Star, then, net zero ready building, and then Passive House. And Passive House was by far and away the richest incentive. It was like $37,500.
Yeah, it was incredible.
Yeah, it's an incredible incentive. And then if you went and electrified, I think you got a $10,000 incentive from the state coupled with that. And with some other things, you could be up over $50,000 in incentives pretty quickly. Of course, most of the people sadly are underinsured. And so everybody is just desperate to try to get back into shelter. So I don't think they were as widely taken up as one would have liked to have seen, but a number of folks have and are building back to Passive House with those incentives, which has been tremendous.
Any other states doing this with you? Any kind of, even 1,000, 5,000, anything like that on the horizon for Passive House?
It's a good question. I don't see it at the moment. I mean, the one thing everybody's trying to figure out how to incentivize are retrofits to a Passive House level, which is the toughest thing. The fact is, with Passive House, if you are building a custom home or doing an apartment building or commercial or school or any type of building that has, let's say, a little bit of a budget to it, you can do it for all intents and purposes. You can get darn close to parity. So it's within the wash of the construction budget. It's within the contingencies, and it doesn't have to cost a whole lot more. Where we find it breaks down is in the retrofits, where it's just going to be more because it demands you do a lot more to the existing fabric. And so one of the strategies we've done that Passive House has developed around it is a long-term planning, so that you replace the windows when the window life is done, you replace the mechanical system when the mechanical system's done, when the siding, or you can get to the shell, you do the insulation and the air tightness. Of course, it's better to do things in certain orders, but to have a step-by-step process. And yeah, the other key, the tough one economically, is just the production building, where you see the bulk of the market, because the economics are so, apparently so razor thin that it's like basically asking a factory to change, what it's producing. So there's a more complicated knot to untie there. And ultimately, it's going to be code that drives it.
So on that, though, you talk about, saying that they're fairly parallel, except when we get to production builders. Obviously, production builders are, slap and go, really tough to even get them to continuous insulation. So if we've got continuous insulation required on production building in a state, then how distant is it to passive house? Is it
It's
5
not that
more?
distant.
Is it 10% more? Is it
I mean, the
10%?
production builders should, it's always just hard to know how the numbers are running, but my gut tells me that they should be able to do it at 5% more. Who knows what their apples to apples are, but if they've got continuous insulation, it's a little bit more insulation. It's the air tightness, which, in many places, it's more and more common to require air tightness in a blower door test of some level. It may be 3 or 5, but it's a number. And the fact of the matter is, if you are making any attempt at air tightness and you have a wrap on the building, and with some intention, you can get to the numbers. It's not, you're not jumping the Grand Canyon. It is really close. We've seen regular construction companies with regular workers who have no conception one way or another, like of, what's going on in terms of high performance and what, high performance, needs to be, with a very little bit of training done with, and the work done with intention to hit certain things, they produce passive house results. And, it's just not that, and we see them, the workers actually get into it because things happen, like you're working in a building in the middle of winter and it's freezing out and there's no insulation in it, but it's airtight and they don't have to provide any heat. They're working inside the building in their t-shirts and they're comfortable and they're like, what's going on? We don't have any heaters on in here and the place isn't insulated yet. And they're like comfortable.
That brings me to one of the things I heard you say, and I want you to explain what this means to people. But what does it mean to say comfort can be achieved solely by post-heating or post-cooling fresh air mass? What that sounds like a really scientific way to say something super easy.
Yeah, well, I don't know how easy, but yeah, it's scientific. It goes back to that principle of aligning hygienic ventilation, thermal comfort, and energy efficiency. So you start with the hygienic ventilation because we want to have a healthy indoor air environment. And for a high performance building where you're supplying air to all the rooms, you're exhausting, you want that to be 100% supply and 100% exhaust. You actually don't need that much airflow to maintain high indoor air quality. It's not like an air conditioning system where you're blowing and it's not loud. It's like 20 CFM into a bedroom running continuously. And you can maintain incredibly high indoor air quality. Now, if we say you only have that airflow to carry the heating and cooling to maintain thermal comfort, now that's a very small amount of heating and cooling that you're allowed. Now, all of a sudden, your enclosure has to be well insulated, has to be airtight, has to have all these qualities. So the efficiency of the enclosure is allowing the hygienic ventilation to provide the thermal comfort. It's all bringing it together. So that's the fresh air mass is carrying the heating and cooling. Now, it doesn't actually work that way. That's kind of the functional definition. It's like, I would say it's the theoretical Platonic definition. You can certainly do it. And if you can, it's a great service in a way because you're eliminating a bunch of systems. And people are trying to figure out like the next generation of mechanicals to see some new strategies at delivering it. But typically, we're going to separate the heating and cooling. It's typically going to be air source heat pump to provide both heating and cooling. You're just, instead of, again, the 12-ton unit, you're putting in 1.5 tons, 2, 3 tons, and you're providing the ventilation with a dedicated system. And rather than the ventilation being a bath fan running intermittently or the kitchen, where you're relying on the leaky enclosure to provide the fresh air, you are controlling it. You have control of the interior environment with air tightness. And basically the idea is to control the quality of something efficiently, you need to control the thing itself. Once you have control of it, it's quite easy to maintain high indoor air quality. So get control of the air, supply it to every space that you're using, exhaust it predictably so that you've got good circulation, and just let it run. And then you've just got the same fan. You have a high efficiency fan. You've got the core doing the heat recovery passively and maintaining that comfort. So
you say hygienic fresh air.
yeah.
So what do you mean by hygienic? Are we talking a MERV 13 filter, HEPA?
Yeah, you can. You can. Yeah, certainly that's having a high level of filtration is desired. And basically the hygienic ventilation is to have the flow, quality of the air, the placement of the air, so it's predictable, so that you're keeping the particulates down, right? That it's not becoming, whether it's CO2 or other outdoor air pollution or combustion pollution from the inside, cooking and whatnot, that you're maintaining a high level of quality. So the hygienic is just the shorthand for that.
Okay, that makes sense. So now when you look at the walls and windows not losing any BTUs, you have these long running systems, steady, clean, fresh air. How does architecture play into all this passive house? Because I know what's going to happen. Somebody's going to go talk to their builder. They're going to say, hey, you should do this. Would my builder have to redesign everything about the home they build?
It depends.
I was afraid of that. That's a yes.
No. Well, everything is a little strong a word. So what's cool about it is, and people are fearful, and architects are not all, but some are fearful about what it means to their design freedom. Because you can't just do anything anytime and rely on power to overcome everything. But the fact is that what it's doing, and what's exciting to architects that I think that come around and get it and work with it, and the builders too, is that it's empowering the architecture itself. It's empowering the structure to deliver the bulk of the performance. What's driving the performance of the building is the building itself. It's not the mechanical system. And so it's the origins of Passive House are really vernacular architecture. Really, it's just basics, learning from the ancients, learning from regional architecture in terms of, orientation, in terms of massing, in terms of exposure, solar exposure, and all of that. And, bringing the rigor of modern, calculations and optimization. But basically, it's the same ingredients, it's the same construction. So you don't have to rethink how you're working with all these things. There's some things that may be, new, but it's not wholesale replacement. And it's more just a shift in how you're looking at it and seeing these other aspects of the building and what you're doing reveal itself. And so that you're working with the energy, with the structure, with the design. So you're designing not oblivious to the ramifications in terms of comfort and energy. So we have buildings that are overglazed, right? And they're absolute greenhouses, that are saunas that have to be super air conditioned, or they're, so sunny and bright that they're uncomfortable. So we're thinking about shading, and we're thinking about, these fundamental attributes. So I think builders, the ones that come into it, they get excited about it because it's really putting, without the rocket science. It's a little bit more complicated because you're calculating it to be predictable, but it's much more about the intent. And when they get to it, it's about empowerment, really. I mean, I think the basic high level summary is post World War II, cheap energy. We could engineer our way out of anything, just blast away. You could build a glass box in the desert and air condition the heck out of it, and you're good. Now, where we have more energy insecurity and sustainability issues and want, better economics, we can re-empower, like before, going back to our grandparents and our great-grandparents, right? And traditional way of looking at really empowering the building itself to do most of the work. So it's quite interesting in that way. And it's bringing these different aspects, strengths together.
I like that. So obviously you have a passion about this, and I know that you guys have a class. You also have free resources. I mean, when I started looking into this, there were so many people hosting webinars like every other week. It's like these, don't take this wrong, but it's like all these little passive house addicts trying to
Yes.
support each other, starting class with, my name's Ken and I'm a passive house person,
Yeah.
So, but
That's fair.
but talk about the class and just what is Passive House Network, so that if some of these guys want to suggest this to their builder or they want to check it out more, where do they go? And
Yeah.
what's
So
next?
So the Passive House Network is really about capacity building. It's about connecting people for peer-to-peer knowledge sharing. So kind of like what you're saying when you come together, and I'm a passive house addict and I want to know how to do it better, and figure it out. And so it's an amazingly open and giving community in terms of sharing. It's not like everybody's got their trade secrets. It's all on the table, and everybody wants everybody else to do better. Because it is, people want it to work and want it to figure out how to make it work. So we have formal training that's really oriented towards building designers, architects, engineers, as well as a broad array of events around bringing together those folks and a whole bunch of other folks. Contractors are definitely in the mix at all kinds of levels, the builders. There is specific building training, and the leaders of that training in the US are called EMU Passive. They're out of Fort Collins, Colorado, and they do training around the country. If you go to passivehousenetwork.org and our website, we have a link to them for the builder training. And that really gets you under the hood and into it. Again, everybody doesn't need a PhD in passive house. Like there's most of the folks working need to know a couple of key things, but you do need people that are taking responsibility for the project and delivering it and understanding the optimization to get it under their skin to a point and take the education deeper.
I like that. Well, I have to tell you, you did a good job of demystifying it.
Oh, thank you.
And I really want to thank you for your time coming on today. So, guys, if you have any other questions about Passive House or on any of the products we carry or any of the things that you see on our podcasts or our blog, reach out to your local branch, reach out to any of us at IDI, where we look forward to earning your business every day.